Okay, so now let's move to arithmetic and geometric sequences. It's something that I put here. Arithmetic and geometric sequences formula. So first, what's arithmetic sequence? It's a sequence in which each successive term is obtained by adding a fixed number, let's call it D to represent the difference, to the predecessor, right? So basically, for example, if you look at this one is an arithmetic sequence because the first term of the sequence is 2, and then by just keep adding 2, you move along the terms. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, and so on and so on. So what that means is that, again, if you take any pair, any neighboring terms, and you take the difference of successor minus the predecessor, 6 minus 4, that's 2, and so will be 4 minus 2, and so would be 8 minus 6. So the difference between any two terms is always the same, right? And of course that could be also, the difference could be negative, keep that in mind, like 100, 95, 90, 85. So what basically is being, what do I have to, what's the difference between any two terms? If you take what's successor, 95, minus the predecessor, it's negative 5. Because obviously to move along the terms, you have to subtract 5, right? Which means that's your difference. And so sometimes it's negative. Okay, so what's the nth term formula? So nth term formula is the formula where, okay, you can take any, if you have, I'm going to give you an example of this sequence. You can also here say that this is your A1, your first term of the sequence. This is your A2, 6 would be your A3, and so on, A4. And all is nice, you can keep listing the terms of your sequence, but someone can ask you, okay, what's like 200th term of the sequence? So what's A200? And of course, you could list all the terms up to 200, but that's a lot of work, especially if someone say even gave you, 1000th term. That would be ridiculous to list all the terms in front. So if you could come up with a general formula, meaning somehow depending on n, then whatever n is, so if you want to find 200th term, you just plug in place of n 200 to that formula, and you can calculate it without the necessity to list all the terms before. Okay, so the general formula is very obviously very useful, and there is a specific formula you can devise, and I'm going to show you how. Because for example, if you look at A2 is always A1 plus the difference, right? So if you add in this case the difference was 2. So if you add to the first term this fixed difference D, then you're on the second term. But if you add another difference D, then you're at the third term, right? So if you add to the first term twice the difference, so one, I'm gonna put it in green, one time the difference, the second time the difference, that puts you on the third term, right? Now the fourth term, to get to the fourth term, you need to add the 3 times the difference to the first term, right? Because then again, you add 1, 2, another 2, and another 2, 3 times 2, to get to the fourth term. So notice, and you can repeat that. So notice what happens is that this index, which is our n, this running index, shows up somewhat here. Those are correlate. Again, A5 would be A1 plus 4 times the difference. So notice whatever that index n is, here is 1 less than it, which means that the general formula for the an is A1 plus n minus 1 times the difference. So again, and it's listed there above. So it means that if I want to get to the fifth term, I have to add to the first term 4 times the difference. If I want to get to the 100th term, I would have to add 99 times the difference to the first term, and so on. Okay, so basically what does it mean to come up with the formula for any term of your arithmetic sequence? You need A1 and you need the difference, those two ingredients, and that will establish then the formula. Okay, and we're going to go over examples in a minute. Before we do, I want to move to geometric series. Geometric series is a slightly different story, because here instead of adding, you're multiplying. So, and I'm gonna here do geometry above. So for the geometric series, for example, 2, 4, 8, 16, 32, 64, and so on, what happens is that you move along the terms by multiplying each by this constant we call it ratio r, which means again that, so in this case you multiply by 2 and you move along the terms, right? Now, which again means that this ratio r you could also calculate if you grabbed any two neighboring terms and you divided the successor by the predecessor. So 16 divided by 8, that's 2. So is 32 divided by 16. So is 64 divided by 32. So the ratio between any two neighboring terms is the same, right? In this case 2. Or you think of it that by multiplying by 2 you move along the terms. That's your geometric series. And similarly you could find out that if you just want to establish based how to get to the second term, well, you have to multiply by the ratio A1. So to get to 4, you just have to multiply the first term by this ratio, in this case 2, right? Now, to get to the second term, in this case, to the third term, in this case 8, then you have to multiply A1 twice by the ratio. Because multiply 2 by 2, that's going to give you 4. Multiply again by 2, that's going to give you 8. So you're multiplying by r to the power 2. To get to the fourth term, you multiply the first term 3 times by r, right? Each time you multiply by r, you move along. So to multiply, to get to the fourth term, you have to multiply 3 times by that ratio, whatever that is, on our example 2. So that gives you r to the power 3. So again, if you compare this index with the power is 1 less. So an is a1 times r to the power n minus 1. And this is your formula for the geometric sequence. Sorry, n minus 1, not n plus 1. I said n minus 1 and wrote n plus 1. So this is your formula for the geometric sequence. Again, all you need is to know what's a1, and in this case, what's the ratio. N remains like your variable, like your index, okay? Okay, so let's look at the examples. In each of the following list 3 terms that continue the arithmetic or geometric sequence, and then identify the sequence as arithmetic or geometric. Find the nth term and the 100th term for the sequence. So first thing, let's start with identifying, are we dealing with geometric or arithmetic? Then let's find few next 3 terms that should be on the list, and then a nth formula. So here, to get from 1 to 3, you add 2, you add another 2, it's 5, you add another 2 is 7, you add another 2 is 9. So since to move along the terms I have to add the constant difference, then that's arithmetic, right? If you have to add to move along the terms, that's arithmetic. If you have to multiply, that's geometric. And I also can tell that the difference d is 2, right? Because to move along, I just have to keep adding 2, right? So that's my And that's my difference. Of course, knowing the pattern, I can also, I should have left some room there. I can also list next three terms, because add 2 to 9, that's 11, another 2, that's 13, another 2, it's 15. So we have next three terms listed. And finally, I know for arithmetic sequence, the formula for an is, I'm going to write it down, a1 plus n minus 1 times the difference, right? So remember, you're moving to the first term, n minus 1 times the difference to get to the nth term. Okay, so if I know the difference, which I do, it's 2. And if I know a1, which I do, the first term, which is 1, then I can come up with that formula, 1 plus n minus 1 times 2. And I would like you to simplify it. Very often it's easier to distribute this multiplication by 2 and combine like terms. So 1 minus 2 will be -1, and 2n doesn't have a like term. So this is the general formula for the nth term. And if you have any doubts if you did that correctly, of course check, because I know that say this is first, second, here let's say 9 is which term? 9 should be a fifth term. So you can quickly calculate, if n is 5 here, 2 times 5 is 10, minus 1 is 9. So it kind of agrees with what I see. And to find the 100th term, as I'm supposed to do, that means that n is 100. So that's 200 minus 1. So 199. So the 100th term for the sequence is 199. And of course, I didn't have to list all the 99. I didn't have to keep adding 2 up to the 100th term, because I know the general formula. Okay, so let's look at this. Is arithmetic or geometric? I see that if I keep adding 50, I get to the next term. So I know the difference is 50. So this would be 250, this would be 300, and this would be 350. Now I can tell that a1 is 0, that's the first term. The difference d is 50, right, between any two terms. So then an formula is a1 plus n minus 1 times the difference. So an in this case is 0 plus n minus 1 times 50. Of course, 0 I can ignore, then I can distribute 50, multiplication by 50, and that sometimes it's maybe nicer formula. So if I now want to find a 100th, that's going to be 50 times 100 minus 50. So this will be add 0 to 50, right? So that's a 5,000 minus 50. So that's going to be, I'm gonna maybe write like final answer, 100 would be, so 100th term would be 4,950. Okay. Now here, like, should I add 3? Well, no, because if I keep adding 3, then 6 plus 3 should be 9. But if I multiply 3 by 2, I will get 6. Again, multiply by 2, you will get 12. Again, multiply by 2, you will get 24. So that means it's a geometric sequence. And by multiplying by 2, I can get to the next term. So 48 multiplied by 2, 96. 96 multiplied by 2, so that's going to be 192, right? 90 times 2 is 180. 6 times 2 is 12. So 180 plus 12. And then 192 times 2, so that's going to be 384, right? So remember, we're supposed to list next three terms. I already identified as geometric. I need a1, first term. And then in the case of geometric, I need the ratio. And I know I just have to multiply by 2 to move along the terms. So that means the ratio is 2. The formula for the nth term is a1 times r to the power n minus 1. So in this case, 3 times 2 to the power n minus 1, and that's it. You cannot really simplify. Don't make a mistake of multiplying 3 times 2, because you first raise to the power and then you can multiply. So you would have to first raise to the power n minus 1 to be able to multiply by 3, and not first 3 times 2. So you cannot do anything with it. That's the nth term formula. So then if someone wants to find 100, that's going to be 100 minus 1. So 3 times 2 to the power 99. And I'm not going to attempt even to use a calculator for, because it's a huge number. Okay. And this is, I think here those commas are misleading, because the terms here are, let's just forget about those commas. So the first term is 10. The next term is 100. Then is 1,000. Then is 10,000. Then is 100,000. So I can see, but if I keep multiplying by 10, I move along. So basically I have to keep adding zeros, right? I had 5 zeros, I'm gonna have 6. Then another term, 7 zeros. And another term, 8 zeros. And those would be your next 3 terms, right? So it's a geometric sequence with A1 being 10, and the ratio is 10 as well. So the formula for geometric is A1 times R to the power n minus 1. In this case, 10 times 10 to the power n minus 1. And here, well, we can't quite simplify, but it's very tempting for me, at least if you left it as such, is fine. But since the base is the same, those happen to be base like expressions, because A1 and ratios were the same, then you can, if base is the same, then you can add the powers, right? So that would be 10 to the power n, 1 plus n minus 1, right? So you add the powers, and if you add n minus 1 plus 1, then you're left with n. So the very nice formula. And of course, to find 100, it's a huge number, because it would be 10 to the power 100. So it's 1 and 100 zeros. Okay. And the next one, 9, 13, 17, 21, 25. So I think we all see we keep adding 4 to move along. So keep adding 4, 33, keep adding 4. So it's an arithmetic with A1 being 9 and the difference being 4. So AN is A1 plus n minus 1 times the difference. So in this case, 9 plus n minus 1 times 4. You can simplify it by distributing 4 and then combining like terms, 4n plus 5. So you have the formula for the nth term, and of course then you can find 100th term by plugging in for n 100, so that's going to be 105. Alright, so I think just key here is to know the formula and being able to recognize what is the difference if you're dealing with arithmetic, and what's the ratio if you're dealing with geometric. But here, let's look at the next one. Count the number of terms in the list. So here we just want to know how many terms we have in this list. Now, well, depends. Here we're going to again rely on the recognizing whether we're dealing with geometric or arithmetic sequence. We're going to come up with the formula, but this time we're going to want to know to what n the last term corresponds. So basically, is it a 10? Is it a 100? Is it a 19? Because we see 3 dots and we don't know what that last one stands for, right? Which term is it of your sequence? But beginning would be the same. So let's recognize it's an arithmetic, right? Arithmetic has formula an equals a1 plus n minus 1 times the difference. I see A1 is 6, the difference is 5, so I get AN to be 6 plus n minus 1 times the difference. I'm going to distribute 5 and combine with 6. So the general formula is 5n plus 1. Okay, but that's not what I'm supposed to do. Count the number of the terms. So what n is 156. So basically if I can figure out the index that say that would tell me that this 156 is, say, if n is 10, that would mean that the 10th term of your sequence, right? So I have to figure out what n is for that term, but I have the formula for an, so I can set it equal to 156 and figure it out the n. So subtract 1 from both sides and then divide by 5. So n will be 31, right? So that means that 156 is 31st term in the list or in the sequence, right? So basically A31st is your 156, right? That's what it means. So to figure out what count the numbers in the list, we need to figure out what term the last number in the list is, right? So to what n it corresponds to, because this index n, this running index n, is what counts which term of the sequence the number is. Okay, so let's look at the next one. 7, 14, 28, 54. I can see they're doubling, so I'm not adding, I'm multiplying by 2 to get to the next one. So it's the geometric sequence. A1 is 7 and the ratio is 2. So I can come up with the general formula if I know in general is that. So now I can plug in for A1 7 for R, the ratio 2. But then I want to know this last one, what that one is, right? So I said AN equal to 3,584, okay, which AN is given by this formula. So that means I can now, first I need to divide by 7 to kind of cancel this 7 here, to isolate the exponential expression, okay? And that's gonna end up being 512. You can use a calculator for that. Now 512 is 2 to the power 9. So once you see the same base, then it must mean that the exponents must be the same, which means that n must be 10. Okay, so you try to write both sides as the powers of the same base. In this case, as the powers of 2. So that means n is 10. So actually this is a 10th term, only 10th term. So there are 10, what was the question exactly? Terms in the list. Another is saying that number 3,584 is A10, which means it's a 10th term of the sequence. Okay. Let's do this one here. What do it decreases, and it decreases by 6, right? I keep subtracting 6 to get to the next one, which means it's arithmetic with the difference d being -6, right? If I have to subtract, then it's negative. Because normally I keep adding the kind of fixed number to move along the terms, but if I have to subtract, that means that d, the so-called, is negative. Okay, and A1 is obviously 100, so the arithmetic sequence formula I know is this. So then I replace A1 with 100, D with -6. I first have to distribute multiplication by -6. So n times -6 is -6n. -6 times -1 will give me +6. So an will be 106 minus 6n. Or you can write -6n plus 106. Either way is fine, as long as you acknowledge n term is negative, the number constant term is positive, right? Okay, and remember, I want to figure out this one, the last on the list, to which index n it corresponds to, because then I'm going to know how many terms I have. So I set the formula equal to -212 to figure it out to what term index n the last term corresponds. So I have to subtract 106 from both sides. So that's going to be -318. And then I'm going to have to divide by -6. So that's going to give me n is 53. Always should end up being positive, because this should be a natural number. So that means that a 53rd term of your sequence is that equal to this -212. Basically, we have 53 terms in this list. And here we actually had this geometric sequence again. This is one term, so those parentheses are confusing. Let me separate terms of the sequence by this purple comma. So it's like, right? So we have 10, 100, 1,000, 10,000, and so on. So we figured out that this is 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4. So an formula was 10 to the power n. Remember, we had this example, we came up with this formula here in part D. Remember that we did that by just looking what's A1 and what's R, but some could also notice a pattern without even ever knowing the formula for geometric sequence in this case. Okay, so then obviously if the last one is 1 and 9 zeros, so 10 to the power 9. So this one is 10 to the power 9, that means it's a 9th term. Okay, so you can set, if you wanted to solve it as a equation, you can set that you have the general formula, you set it equal to the last, you write it as a base-like expressions, and n is 9. You compare the exponents. So we have 9 terms in this list. Okay, let's look about finding the sum. So now to find the sum, you do have to kind of follow this Gauss's kind of idea, but you also have to know how many terms you have in the sum. So it goes back to what we just did. So first 2 plus 9 plus 6 plus 23, so on, plus 702. So we are adding terms of what? Of arithmetic sequence, right? Because to get from 2 to 9, you have to add 7, add another 7, add another 7, and you're moving along. So basically, but now we're adding those terms. And if you remember, the idea is to, if you write the same sum in the decreasing order, so here right before 702 you should have 695, add 7, you have this, right? If you reverse the order, okay, plus 3 dots, 9 plus 2. So now you write it from the highest to the lowest, and you add those sums. So now you have twice the sum is 709, right? So 704. The second, 9 plus 695 is 704. they all will end up being 704. We just have to figure it out how many terms. So how many times I'm supposed to add 704? Well, to figure that out, I need to figure it out in this arithmetic sequence. What is the 702, the last term, right? To what index n it corresponds, because that will tell me how many terms I have in my list, meaning in the sum, right? So if I come up with the formula for the arithmetic sequence, an will be a1 plus n minus 1 times the difference. And then once I come up with the formula, which I can easily do because I know what's a1 and I know what's the difference, right? It's 7. We have to keep adding 7 to move along the terms. I can quickly simplify it, distribute 7, combine like terms. And then remember, that's not what really I want. Now I want this set to be equal to the last term in your list, which was 702, right? To figure it out, which term of your sequence the 702 is, so add 5 on both sides, then divide by 7. So n will be 101, which means that we have 101 terms in the sequence, so we're adding, right, the 704 101 times. So twice the sum is 704 101 times. So maybe I'm gonna say 101 times 704, and then of course divide both sides by 2 and use a calculator. If you had to, of course you could do it by hand. That's 35,552. Okay, so let's look at question 6. The first windmill has 5 matchstick squares, the second has 9, and the third has 13, as shown. How many matchsticks squares are in A, the 10th windmill, B, the nth windmill, and C, how many matchsticks will it take to build the nth windmill, right? Okay, so first let's look at try to kind of figure out the pattern. So now if I count how many squares, right, not matchsticks, so squares first, how many squares are there? The first one has what? 5 squares, right? The second one has 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this one has 13, right? Because 4 times 3 plus 1, okay, 13, and so on, and you can kind of keep building, okay? So what because you just keep like adding 1 square to your arms. So basically what ends up happening, the pattern is like that you just, on the arms, you keep adding squares, right? So you keep adding 4, 1 on each arms, right? So that's an arithmetic sequence. The next windmill would have 13 plus 4, 17, right? Squares, because we have to add, to get to the next, you would have to add 1 square on each arm. So 4 total. So it's an arithmetic sequence where A1 is 5 and the difference is 4. So of course, to answer the question B, okay, I'm gonna to answer A, I'm gonna actually answer B first. How many do I have in the nth? You can do it that way or you can observe the pattern, but I'm gonna do it first that way. So nth, basically, what's the nth? The formula for the nth term. I know it's A1 plus n minus 1 times the difference for arithmetic, where I know what's A1, what's the difference. Simplify it, and you get that AN is 4n plus 1. Okay, so that means to answer A, I'm gonna work backwards. The 10th one, right, would be 4 times 10 plus 1, which is 41. Okay, so the 10th windmill will have 41 squares. Okay, in general, so nth windmill will have 4n plus 1 squares. Okay. And now, how many matchsticks will take to build the 10th windmill? So sticks is different than squares. If you look at matchsticks, then here you can count. You have 16 because 4. I'm counting those outer 4 squares with 4 matchsticks, so 16. Then this one is 4 like before, right? 16, and then another 12, so 28. Okay, this one you can count 40 and so on, right? So here it's also, right, arithmetic, but the difference is 12. You add 12, you have 28, right? You have another 12, you have 40. Because why you keep adding 12? Because you keep adding, you're building the squares on those 4 arms, but that means you're adding each square. Well, you only add 3 sticks, right? So 4 times 3 is 12. Every time you're going to add 12 more sticks to build those extra outer squares. Okay, so that's also arithmetic, but A1 is 16 and the difference is 12. So since C wants us to count how many matchsticks will it take to build the nth windmill, so AN, but with A1 equals 16 and the difference equals 12, so I can plug those in, or the difference. Let me write the general formula first. You distribute 12 and minus 12, and then combine the constants. So 12n plus 4 is the answer for C, right? So the next question 7 is, Joe's annual income has been increasing each year by the same dollar amount. The first year his income was $24,000 and the 9th year his income was $31,680. In which year was his income $45,120? But basically we know we're dealing with arithmetic sequence because each year his income is being increased by the same amount, right? So that's the first year. Then I'm gonna use commas here in purple. The next term, I don't know what it is. I don't know what's next, but I know the 9th one is, because that's the 9th year, is 31,680. So I know this is the first term of the arithmetic sequence, and this is the 9th term. Right? Okay, what do I know is A9? A9 is the same as A1 plus 8 times the difference. Remember, the general formula is n minus 1 times the difference, meaning for the 9th term, you just have to add 8 times the difference to the first term, right? So I know A1. If you look at this formula, you know what A1 is. You can plug in a number for that. You know what A9 is, what the 9th term is. You can plug in the number for it. You don't know what's the differences that increase in the income, but we'll be able to solve it. So let's plug in the numbers. and I'm gonna reverse here the order. I'm gonna put this on the left side first. So A1 is 24,000. D, I don't know what is, but that should be equal to A9, and the ninth term is this. So you subtract 24,000 on both sides. So AD will be equal to 7,680, and then you divide by 8 both sides, so the difference D will be 960. That means that each year his income increases by $960. So in which year will his income be 45,120? So now we kind of can come up with the general formula, right? AN in general is A1, which I always knew to be 24,000, plus N minus 1 times the difference in general, right? For when N was 9, I put here 8 times the difference, but in general is N minus 1 times the difference. So we can come up with the general formula, a little bit simplified version, by distributing 960 and then combining like terms. So AN is 960 plus 23,040. And you can be asking, why do I do that? Because I want to figure it out in which year his income was this. So to what N? Because the first year is A1, right? The second year's income is A2. So I want to know to what index N this 45,120 corresponds to. Of course, one way to do that would be to keep adding 960 until you get to that amount. That's approach 2, but sometimes it might take you a long time, especially if the number given is far away from the ones you have, right? So the more mathematical approach would be to find the general terms formula for AN, and then set it up equal to the term you try to figure it out, in this case 45,120, and solve for N. So I'm going to subtract 23,040 from both sides. So that means it's going to be 22,080, and then I'm going to divide, again I'm using calculator, 960 on both sides, and N ends up being 23. So his income was $45,120 in the 23rd year of work. Okay.